What you see here is these are alivitum animals that they were lacking the SIRT1 gene, so they lived shorter than the normal live animals. And if you put them under caloric restriction conditions, you actually see absolutely no benefit of the intervention. And if you have either one copy or two copies of the gene, then you restore the capacity of the animal to respond to caloric restriction. So this provides genetic evidence that SIRT1, at least in part, is participating in the beneficial effect of caloric restriction on survival. And we're now looking at what are the particular genes that are missing when you put the downstream genes that are missing on the animals that they were induced caloric restriction in the absence, on the presence of one or two copies of SIRT1. So to summarize this part, I think that caloric restriction does remain a very robust intervention to extend mean and maximal lifespan. But like you will know in humans, every time that you put something through somebody's mouth, it is not a straight shot out. So we need to make sure that when we do dietary interventions and we're trying to understand complex things like caloric restriction or aging, we take a number of factors into consideration before we implement the diet. So where do we go from here? So when I started in the field, there was, the gold standard was caloric restriction. Now we know that caloric restriction is a yes, but, take into consideration other things. So where we are in what we call the search for caloric restriction mimetics. Can we really, through interventions, make us live long, young, and strong? So over the past 10, 15 years, there's been an explosion of interventions and development of drugs and compounds that have acted through what we are calling the master regulators of metabolism, and that have been tested in a very unbiased model in a multi-site way in mice. And I'm going to give you some examples of this. So we know that we have a non-genetic intervention for lifespan extension, that is caloric restriction. We have resveratrol. We have SRT-1720 that I showed you some data. And we have also metformin. This is a compound that is very used for diabetes. Now, we also have rapamycin. It's a drug that is used as an anti-inflammatory during organ transplant. And one thing that is very interesting is that if you look at rapamycin, the effect of these particular compounds is very, very different between males and females. Very much like caloric restriction was working very differently between males and females. And now we have another compound that is also a diabetic-like drug that is acarbose, that in this case works much better in the males than in the females. So again, we have a dimorphic effect of interventions in males and females. So when we're trying to put some of these findings into the clinic and into people, we need to consider, I think, sex. We need to consider genes, diet, and parts of the environment. So we know now that there's a number of targets that we have been successfully targeting, both genetically and with compounds that have profound effects on survival and health. So we need to be focusing on the developing and implementation of this and try to understand when and how are the best times throughout the lifespan of a particular organism to give them to them to maximize health and slow down aging processes. So I think that CR is still a very robust and useful intervention to extend health span. The lifespan aspect of it, I think, now is becoming into question. I think that the lifespan extension by caloric restriction, as I explained, is very much context dependent, and context, I mean environment, genes, diet composition, etc. I think that we have an urgent need to identify what markers of lifespan are markers for lifespan determination. Can we predict if Jay is given metformin, is he going to live longer, or he will benefit more from acarbose, and when he could do it? And then what we're starting to be extremely aware is that a lot of the interventions that we're testing are very sexually dimorphic. So that's something that for me was kind of a surprise, because I didn't expect to see that some of the interventions, if the mechanisms were completely universal across species, I thought that you were going to have a beneficial effect independently in both sexes, or the same level of effect in both sexes. And something that I learned here is to never give up. So throughout the last, 14 or 20 years of my life since I came here, there were a lot of hurdles that I had to go through. And the only way that I did to, what I did to get where I am is to go through a lot of hurdles, and I never gave up. So if you really trust and believe that the path that you're heading is the right path, go for it. And then, life will come to you. So I have to thank, all the work that has been done for the people in the laboratory and for all my collaborators, that they are both in the intramural research program and the extramural research program, and the laboratories within the intramural research program that make possible lots of this research. So with that, I'll leave you alone and I'll take any questions. Thank you.
Questions? Maybe you could just come on over a little bit here.
You cannot do that alone.
Hi. What about advanced glycation end product receptor 1? It's been shown in the last year that actually regulates SIRT1, and that can be modified by diet. Have you looked into that?
We have not looked in RAGE1, no? Not yet. But we have, so one of our collaborators in the cardiovascular department is actually producing a mouse that has either up or down regulated the receptor. Question over here?
Hi. This may have been implicit, so perhaps more or less been answered, but it wasn't explicit to me. Can exercise, for example, basically mimic caloric restrictions such that you could have someone eating, let's say, 2,500 calories,
yes,
but if they're exercising such that they're burning 1,000 more than they would by normal activity, can you mimic these effects in humans?
That's a really good question. That question right now is being investigated. So caloric restriction has not been formally tested in humans. There are a caloric restriction society in the U.S. that has about, I think now it's like about 5,000 people enrolled, and they are providing data to a few investigators. But these 3 studies that were funded by the National Institute on Aging, that they were actually looking at caloric restriction in human in a very well-controlled population. The sites were at St. Louis, the other one was in Pennington, and the other one in Tufts. And one of the studies, the one in Pennington, I think they had a component where the goal was to target 25% reduction in caloric intake. The other one was a 12.5% reduction in caloric intake, an increase of 12.5% of exercise, and then an exercise alone one. And the results of those studies are being published as we speak. So the bottom line is very few people was able to maintain 25% caloric restriction over a period of 2 years. I think they got to about 18 or 18.5%, and there were significant differences in some of the outcomes that they were measured between the exercise or the caloric restriction alone groups. So I think that is the caloric need, what you need to reduce. So if you increase exercise, so energy expenditure, you decrease energy intake, the outcome should be similar. One interesting question that we always get asked when we talk about caloric restriction is, what will happen at the population level? So the answer is complicated and simple. If you took out a whole entire population of the U.S., that the average body mass BMI is extremely high, and you put them on caloric restriction, you're going to decrease the BMI by 5 or 6 points. So by a reduction of 5 or 6 points in the BMI, the outcomes on health are going to be tremendous. Now, if you take a person that has a BMI of 17 and you put them on caloric restriction, probably the benefit is not going to be as great. So that's why, we do not recommend everybody to go into caloric restriction. I think that, the data is coming up that you need to take into consideration multiple factors before you endure some of these interventions. Yes?
I think my question has been answered. Another factor is age. Age and calorie restriction. It would seem to me that might be...
Age and caloric restriction.
Well, because the metabolism changes,
sure.
function of age. And
so I mean, one thing that we know for sure is that all animals, when they reach about 2 years of age, that is about 2/3 of the lifespan, they stop eating normally. So they have a decline on food intake. But there has been some studies where the implementation of calorie restriction was either at 3 months, 6 months, 12, etc., etc. And yes, there is an endpoint where, you take an animal that is 18 months, I think it's past the mean lifespan, the effect of calorie restriction are not that strong. Okay?
So I think it's very, very interesting for you to mention that when in the laboratory animals, only 30% seems to show positive response to the CR, but there are also some detrimental effect in other brain. So I was wondering how that reflects on people. It seems when people talking about calorie restriction, always seems to be beneficial. The other question is when you look at SIR1 activator in your study, it showed mimicking the CR beneficial effect. So is that also genetically relevant? I guess if you try in the brain, the genetic background of mice, let's say, detrimental for a response to the CR, is that also show the similar effect?
So we have, in the latter part of the question, so have we tested down-regulating or up-regulating SIR1 in a different strain of mice? No, we just did it in black sixes. So I cannot answer the question of, that particular gene in other strains. In the context of calorie restriction, so the point is that when we took, this investigator took 42 different strains that they share some genetic information, but they are distinct. They have, about 33% of those did not respond positively to calorie restriction. Now, you have to keep in mind that there are degrees of calorie restriction. That was what I was trying to answer with my 20% and 40%. So is there an optimal restriction per genotype? So can you optimize what a black 6 mouse, restriction is for maximizing health and which one it is for maximizing survival? Is that the same in a white mouse? It is the same on a monkey? That's what we need to try to get at. Yes?
I'd just like to make a short comment for Professor Moskowitz. There are newer pediatric and geriatric literature studies proposing that it is safe to have some aspect of caloric restriction for those populations as well as the general aged population. Yeah. So it used to be very much a caution, but don't prescribe diets for children or for senior citizens, but there are data showing that it can be safe and that it could be a very good thing.
Yeah. I mean, there's a very interesting observation in the basic biology of aging. If you take, mice, female mice only have 8 nipples. So, and they normally have anywhere between 6 to 12 pups. But if you consistently overcrowd the litter, so if you consistently give them 12 pups, then those offspring, they normally live 15 to 20% longer late in life, and they have less, incidence of diseases. Now, one of the things that we're trying to answer as well is how early can you intervene? And, one of the things that we did recently with a postdoc of mine that graduated from my lab and is now an associate professor in Kentucky is we did perinatal intervention. So we put animals to run while they were pregnant. And the animals that they were born from females that they were exercising during pregnancy, they had a much lower risk of getting diabetes later in life or glucose deregulation, all the way, like 2/3 to their lifespan. So, I think that we're starting to have a tool set that is going to enable us to model and to modulate the aging process. Now we need to start trying to understand which tool is useful for what aspect of aging. And I think that when we can, come up with a whole entire garage, then we'll be able to fix the car. Yes.
When you decrease calories, you also decrease energy, right?
Correct.
And they recommend that you exercise.
Yes.
So how in the world are you going to do
So it's a very good question. So one thing that you might want to repeat that. Yes. So she's asking the question that I am proposing to reduce caloric intake, and from the other ear she is listening. You need to increase your exercise to maintain fitness. So they are not incompatible. So one of the things that caloric restriction does, and is one of the things that I've been working on, is to understand how cells that they are in an organism in caloric restriction, how they handle energy. And we have been, identifying the steps in the process of how energy is handled, that they are improved. So with the same amount of energy, you can produce a more efficient work. So if you take, to keep on with the analogy of the Indy 500 and the cars, if you take a Delta 88, okay, that was the largest car ever built in the U.S., and I had one of them when I first moved to Peru. It was like 11 miles to the gallon, or something like that. Yes. Anyway, so if you take that car that had an engine that was I think it was like a 5-liter engine, and you look at a car now that is 5-liter engine, the amount of gas, energy, that the Delta 88 needed to drag through 11 miles was 1 gallon. The new car, you probably go a hell of a lot faster, and it uses, like a cup of glass. So it's just a matter of tweaking and improving how energy gets transferred from one place to the other. So they're not totally incompatible. Animals that they are on caloric restriction, the mice, when you give them a will to run, they will run up to 14 kilometers a night spontaneously, and they do not have increases in food intake.
Okay, I have a question. You said in most of the experiments that you conducted, you reduced the amount of calories while the micronutrients remain the same.
Yes.
And I guess the publication that you wrote, reported about, talked about adolescents, and you could restrict their calories, and they would also have those beneficial effects. But I guess I would caution, and I would ask you, how realistic is that to reduce calories so drastically and still meet the micronutrient requirements?
I mean, you do it in the animal setting and the laboratory setting. You do it by supplementing the diet with the necessary ingredients.
Right, but at the same time, we know that if it comes from food, the body absorbs the fat.
Sure. Yeah, but so the diets that we use in the laboratory have been tested very carefully on health outcomes in the animal. So they tend to be, the equivalent to the RDA for animals. So we know that they are balanced. There's a couple of articles that they were published and studies that have been done, answering specifically that question. Which one of the, what we call standard diets are, when you restrict them, not, beneficial for the animal, and when you need to supplement and when you're not. So there are a set of diets that is used normally in the laboratory animals that if you reduce the caloric intake, you need to bump up the macronutrients.
But I guess when you say how feasible is that?
There's not, so, I mean, the answer you look at around the country, I mean, there's no way that you're going to put the population at 40% CR. So that's why I think that trying to understand how it works, it's like my mentor George Roth always said, can you make a pill that you can have, have your kid and eat it? So.
You said there were certain genetic strains of mice that showed detrimental effects of CR, but those were consciously bred strains where you bred them, right? How do you think that translates to, that genetic strain translates to humans? Is it families? Is it ethnicity? Is it race? And then does that mean that there might be, if we can translate CR to humans, that there might be certain families or races that may not show the benefits?
Right. So the point that I was trying to make, so the genetically heterogeneous 42 strains that they were tested with one dose of CR. That was 40% across the board. and that showed to be beneficial. Arlan Richardson is now doing the same experiment, but doing a dosing of calorie restriction to see the ones that they were not responding at 40%, did it see differences at 20. And that is illustrated with the C57 females. 40 didn't do anything, but 20 was tremendously beneficial. Now, the key question to me is, in humans we do not know who is going to respond and who is not. But if through the animal research we can identify what changes, in you when you have caloric restriction and it's going to work? Can we identify what are the metabolic parameters of the blood markers that we can identify that they will tell me if a given intervention is going to be positive for you? Then it will be safe to just, have somebody come into the physician, they take a blood sample, they say, okay, now you're going to do 20% CR, you come back, they look and say, this looks terrible. Or they can say, this is looking fantastic, let's go to 40. And then it's up to you, you want to be very hungry or super hungry.
The composition of the calories makes a difference.
So that's a really good question. So we know that the diet composition as a whole makes a big difference. But the studies that have done so far, altering diet composition, show that in all cases, calorie restriction improves survival and health, but is the degree of the improvement what is changing? Yes.
Hi. Building on a couple of questions that have already been asked, and one I think I heard you respond, and please correct me if I'm interpreting this incorrectly. We had talked about the mice models where you reduce the number of calories on what they were currently consuming, and I know we're not ready for population level recommendations yet, but considering all of us in the meantime are guilty of exceeding our caloric intake, in reality, in the meantime, till we get to the point of making recommendations for humans, I think the caveat really needs to be, if we do what we're really supposed to be, that will take into account the caloric restrictions that we're talking about, plus meet the nutrient needs that we were talking about, and it will inadvertently provide the caloric restrictions that we are talking about here. But I guess my question really is, if we get to that point ever in a real world or in an ideal world where everybody is doing what they're supposed to be doing, are we still recommending caloric restriction in addition to that, or do you think we're not there yet? So when
I'm going to always go back to the animals. So in an animal setting, in a population of black 6 mice, when you're providing them food ad libitum, there is a huge range of body weights. And the beneficial effect in terms of survival and health are not linked to the original body weight. So it's as a whole, there's an independence on, beginning body weight. So as a population, it sounds like if that transfer to the human population, I think that overall people in general will improve outcomes of survival if you reduce by a percentage the caloric intake. How much of a percentage? We do not know. But, if you have people that they are, extremely active, they have a very well-balanced diet, they are fit, the BMI are low, you are doing all the right things to have good outcomes for health. And we know, like your grandmother told you, eat well and exercise, and you will do well. And I think that if we're able to follow that as an individual is hard, and as a population I think it's even harder, I think that we'll do much better.
Thank you.
Yes.
Any special diet for humans who are incapable of exercising at all?
So, unfortunately, I don't have...
What's the question?
The question is, do we have a diet that can substitute exercise for people that cannot exercise? So, very much like caloric restriction, there is groups of people trying to develop exercise mimetics, that they are compounds that will produce changes in the muscle, very similar to the ones that if they do exercise. But, exercise is not just the effect of the muscle. There's a lot of things that go on in the body besides the exercise. And I think that any exercise is better than none. There's a few Northern European studies that I think they have measured energy expenditure in people that just are tapping their fingers, when they're sitting. And that little increase of energy expenditure has, consequences in survival. So I think that even when you are, not able to exercise per se, I think that increases, in activity are very, very important. And the very interesting thing now, you can have, one of these wristbands that can tell you how much you're moving. And then you can set goals every, that you're going to, increase by 1% every week what you're doing.
Paralysis.
Huh?
Paralysis.
Paralysis is an extreme on not being able to do exercise. So, that is, right, yeah. So that's a different, that is a different context.
It seems, I'm sorry, it seems like Rafa passed in this room about 15 years ago. And didn't he pass again today? Didn't he pass? Very good. Thank you, Rafa. I have to add one little detail that Rafa communicated to me yesterday, that he was really moved by this presentation that Rick Weindrich made at Purdue some time ago, and that was the inspiration for him to get into aging research. I just want to give you one detail. We sponsored that presentation by Rick Weindrich. So if you ever wonder what's the value of going to symposia and colloquia, you might be back here in 15 years giving a keynote. It is my distinct pleasure to thank both of our speakers. You really gave us a lot to think about. Thank you. And I think we've had a great morning. I'd like to do one more important task before we break for the day. In each year, the Center on Aging and Life course confers an award to one of our faculty, our students, or a community member. And the award is to recognize excellence related to our mission as a center. It rotates from research to teaching to engagement. Last year we recognized research. That was actually Dr. Jill Suter and Dr. Megan Gilligan for research excellence. And in this year we're going to recognize teaching excellence. It is my pleasure to announce that Sharon Christ, Assistant Professor in the Department of Human Development and Family Studies and a Faculty Associate of the Center on Aging and Life course, is the winner of the 2014 Outstanding Professor Award. Sharon came to... Yeah, we can do that. Sharon came to Purdue in 2010 from the University of North Carolina. And in addition to her appointment in Human Development and Family Studies, she's also appointed in the Department of Statistics. So that tells you a little bit about what she probably teaches, right? She's a prolific author. She's been a co-investigator on multiple grants examining an array of topics such as aging and chronic disease, pain management, and autism spectrum disorders. As an instructor and mentor, she's probably one of the persons who's just really come on at Purdue in such a very short time. And the graduate students that we surveyed kept mentioning her ability in the classroom and her ability as a mentor. When I looked over those comments, I wanted to just to package 3 themes that I saw in those comments that the students delivered. One was expertise. Quote, "She is extremely knowledgeable about the subject matter and always incorporates the most innovative technology to keep the course materials as current as possible. Dr. Chris' mastery of course materials makes her a remarkable and effective teacher." 2, helps students succeed. She delivers lectures on statistical applications and makes sure students get useful information, what they need for their projects and dissertation. She is an outstanding teacher and a devoted mentor. She always makes herself available to students She's very generous to students and self-sacrificing. And third, dedicated caring. She cares how students acquire statistical knowledge throughout the learning process. In a sense, maybe, Sharon, you're going to get asked to be on more committees as a result of these comments, but please come forward. We would like to honor you. Thank you, Liz.
So I'm just honored to get this award. It was very surprising to me. I had no idea. But I really enjoy working with graduate students. I think it's really the most important thing that I do.
Has it been a good morning? For some of you, we kind of threw you a curveball because we tend to do these in the afternoon, but we really wanted to take advantage of working with the Department of Nutrition Science and did a morning. So on your evaluation forms, feel free to tell us if you prefer morning or afternoon. I don't know that we can always accommodate interests. In your booklet is a purple sheet, and that is an evaluation form. It would be very helpful to us if you could fill that out and drop it on the table outside the room. I believe it's out there. And also, if you want to just recycle your name tags, we have a basket out there that you can drop those in for us. I want to thank each and every one of you for coming. 1 million people, it seems like, helped me put this all together. I don't know if Ann Howe is in the room. Is Ann Howe here? But Ann handles so many details for us. She's an inspiration to our students in so many ways. I personally want to thank her. She's actually headed on a vacation tomorrow and stayed to make sure that everything was taken care of for the symposium. Is that special or what? We had timekeepers, we had photographers, we had all kinds of people helping out. Just really thank you very, very much. And for the sponsorships, we are deeply grateful. I imagine we'll all be thinking about how much we should eat for lunch. Ciao.